To complete the problem, to find the difference in the surface area, we're going to have to find the surface area of the Walter Pyramid. We do have the surface area of the Great Pyramid earlier in the activity. I'm noticing here that the dimensions for the Walter Pyramid are given in feet, which is the imperial system, whereas when we worked with the Great Pyramid, we used the metric system. So I'm going to make a list of the things I'm going to have to do to figure this problem out. So the first one, I'm going to convert feet to meters. And then I'll be able to use the formula for the surface area of a pyramid, and I'll start with finding the area of the base. I have those dimensions. Then I can find the slant height. So I will use the Pythagorean theorem to find the slant height of the pyramid. And recall that is the length along the triangular side. Using the once I have the slant height, I'll be able to find the area of a triangular face. And after that, I can find the total area of the base plus the 4 triangular faces. And then the last thing I'll do is I'll find the difference, subtract those two values. To do the conversion from feet to meters, we can look online and we can find that 1 meter is equal to 3 28/100 feet. So I'm going to use this conversion factor to write an equation. And what I'm going to do is I'm going to use feet as my independent variable and meters as my dependent variable. I know that the equation will be the general form, y equals mx, because the y-intercept will be 0. The line will pass through 0, 0. And as I write my equation, I know that for every 1 I go up, so the rise of 1 will be, there will be a run of 3.28. And so I know that for the rise of 1, I will have a run of 3.28, and it will be multiplied by x. So I will be able to use this formula to determine the lengths in the metric system. So I will start with the side length, and I'll substitute that value for x, which is 345, and that is 105.2 meters. And I'll repeat the use of the equation with the other length, which is 191 feet, and so that is equal to 58.2 meters. I can label my diagram with the measurements that I now have in the metric system, and so the side length is found along the square base, and the height is the internal height, 58.2 meters, that height that meets at a right angle to the base. So the first thing I will now do is I'll get the area. It'll be step number 2, the area of the base. I know that it's a square base pyramid, so the formula is area is equal to s squared. Our length is 105.2, and we're squaring that, and that is equal to 11,067 meters squared. To determine the slant height, we have to look at that internal triangle. And I will indicate that in red. So it is that vertical height. We go along the base to the edge, and then we also have our third side is going down that slanted triangle. So if we redraw the triangle, we have a height of 58.2 meters. This part along the base is half of the base, so it's 105.2 divided by 2. And then this is the length that we're trying to determine. The Pythagorean relationship using the variables that we've used, h squared plus t squared is equal to L squared. And so h squared is 58.2 squared. T, which is half of the 105.2, is 52.6, and we're squaring that, and it's equal to L squared. L squared is equal to 6,154, and when we take the square root of both sides, L is equal to 78.5 meters. The next step is to determine the area of the triangular face. And so that we know that the area of the triangular face is 1/2, and it's multiplied by the base, which is S, and then it's multiplied by the slant height, which is the value we just found. And so we'll have 1/2 times 105.2 times 78.5, and that area is equal to 4,129.1 meters squared. The next thing to do is to determine the total area. So the total surface area is equal to the area of the base plus 4 times the area of the triangles. So the area of the base is 11,067 meters squared, and we will add on 4 times the area of the triangular face, which is 4,129.1 meters squared, and the total area is equal to 27,583.4 meters squared. The area of the Great Pyramid was much larger. The area was 135,194 meters squared, and so we're going to subtract 27,583.4 meters squared, and that difference is equal to 107,610 meters squared.